Welcome to CognitionChunks. This information is for entertainment only. I am not trained in physics. Is this useful? Episode 16. Entropy as a measure of state multiplicity or information content. Hey everyone, today we're diving into a topic that sounds like it belongs in a high-level physics class. But trust me, it's super interesting and relevant to understanding just about everything in the universe. We're talking about entropy, not just as some mysterious concept, but as a measure of state multiplicity or information content. Let's unravel this together and find out why entropy is crucial in both physics and information theory. What is entropy, really? Let's start by simplifying what entropy really means. In the most basic terms, entropy is a measure of disorder or randomness in a system. But it's so much more than that. It tells us about the number of ways a particular system can be arranged without changing its overall appearance. Imagine a room full of colored balls scattered randomly. The more ways you can rearrange those balls without the room looking any different, the higher the entropy. Entropy as state multiplicity. Think of entropy as a way to count how many different configurations or microstates can result in the same general condition or macrostate of a system. For example, if you have a gas in a box, that gas can have particles arranged in countless ways and still have the same temperature and pressure. That's its entropy. It's like having 100 different paths to get from your house to the store. The more paths there are, the higher the entropy. Now let's flip this concept into the realm of information theory. Here, entropy measures the unpredictability of information content. In simple terms, it's a measure of how much information you're missing when you don't know the state of a system. The more uncertain you are, the higher the entropy. Think about receiving a message where every character is equally likely to be any letter of the alphabet. Deciphering that message has high entropy because it's so unpredictable. Let's do a quick mental experiment. Imagine you have a deck of cards. If all the cards are randomly shuffled, the entropy is high because there are a vast number of ways those cards can be arranged. Now if you sort those cards so all the suits are together and in order, the entropy decreases because there's only one way to arrange them in that order. The cards are now highly ordered and the entropy is low. Understanding entropy is crucial because it drives many processes in nature, from the melting of ice to the formation of stars. It's also foundational in understanding how information is stored and processed in computers, and even in measuring the efficiency of engines and other systems. In essence, entropy helps us understand not just how things work, but how they deteriorate, evolve, or maintain order. There you have it. Entropy isn't just a fancy term used by scientists, but a fundamental concept that explains how things change, how information is handled, and even how we can predict the future states of complex systems. It shows us the hidden patterns in chaos and the unexpected order in randomness. If you loved learning about entropy and want to dive deeper into more fascinating science topics, make sure to hit that like button, subscribe, and ring the bell for more awesome content. Thanks for watching, keep that curiosity alive, and remember, the universe is a lot less mysterious when you understand the science behind it. See you in the next video. Thank you for joining us for another Cognition Chunks.